All right, I'm back. Show me in the camera. Something board? Yeah, I think that's it. All right, so we're good? All right, we'll wait a few minutes for everybody to come back on. Again, I apologize for that. You have an error, Victoria? Okay. All right, we'll wait till everybody get on. I had to reboot my internet. It should be good now. All right. So we left off. So we understand how to do B part of 56 now, because that's going to be probably going to be on a test. It's something we need to know. Okay, good. All right. So what we're going to do now, we're going to continue. So any homework questions from the homework? Do we need to answer any of those questions? And if we do, what problems do we need to look at? So just put the problem 77. Okay. All right. What else we got? 83. Oh, no. We're going to do 83 today. So if you did up to 79, remember I told you don't do the stuff when they talk about the expected mean. So 81, 83, we're going to work that. We'll work that today. We'll learn about that today. 69. 77 is up there. So if you stop at 79, anything 79 and below, we'll show you how to do 83 and 81 today. And the rest of the problems that was on the blog. 70? Did I give you all 70? We'll look at 70. Let me see, where is 70? Oh yeah, we'll look at 70. All right, what else we got? Talk to me. You all just don't know how happy you make me being on here, because I know some teachers probably got 2 or 3 people on their blog. I mean, that's going live. So that means you care. All right, what else? So that's it. 69, 70, and 77. All righty. Okay, so 73. All right, and 70. So whatever. All right. So if you look at, so we're gonna start with 69. So basically 69 and 70, just making sure you know what the rules are. So we're gonna go over the rules again. Okay. So you need it's 4 rules that you have. 4 of them. You need make sure you have success or failure. You got to make sure that the outcomes are independent and have to make sure it's a fixed number. Then each trial in the very beginning should have the same probability of success. Okay. Then your binomial distribution starts at 0. All right. So if you look at number 69. So 69, they give us the probability of success. And so the probability of success that's P. So P is your success, what we're looking for. And that's going to be 0.85. All right. And then they also tell us that we have a fixed number. N is equal to 20, not 19, not 21, not 24, just 20. So that's going to be your fixed number. Then your success or failure. So if I go here, this is rule 4. All right. And then if you read you go out to 69, so they tell us that so the only thing we have left, so we have a failure or a success. Okay, so in other words, that means that they're going to germinate or not. And then, so we're going to assume that they are independent. All right, so when you go pick up that bag of seeds, you should have an 85% of success. Then you only pick just 20, so that's your fixed number, and you have either they germinate or they do not. Then they should be independent of each other. Okay, all right. So for number 69, that would be considered a binomial distribution. Now, if you look at 70, it tells us that, so that's for numbers, so that's 69. For 70, you have, okay, put the name of all the students in your class in a hat, mix it up, and then draw 4 names without looking. So if you pick 4 names, what's that, from the what's that, a bag? Okay. Oh, hat, I'm sorry. From a hat. You got to remember, you're doing it without replacement. So if you do it without replacement, you're breaking this rule here. Because each time you pick a name out the hat, then you don't have the same amount of numbers that you started with, your sample size. So if your sample size keep going down, let's say it was 25 students. Okay, and then we have 25 students. And then let's say we had 12 girls, for example. Okay, so the first girl would be, the probability of the first girl would be 12 out of 25. Then the probability, and they picking it without replacement. So the second is a girl, given that the first is a girl, the probability is going to change. So wouldn't that just be 11 out of 24? So the probability of success for each one is going to change because you're doing this right without replacement. So this fourth rule is not being followed. So it's not a binomial distribution. Damn. Binomial distribution, that means that when you pick something, you either have a failure or success. Then when you pick something, it should be independent. So picking one thing should not depend on the other. So one shouldn't depend on the other. And then, like we talk about, and when you walk in my class or any class, everybody should have the same probability of getting an A, right? You say, but that's not always the case. But everybody should be taught the same way. If everybody have a question, it should be answered. Okay, so everybody has that same probability of success. And so you only have a fixed number. So if you're taking a test and I tell you that you can redo a test or a quiz, you can redo it twice. So if you fail your test the first time, you can come back and take it again. So that's only 2 chances that you have. So you can't back say, Mr. Burrell, can I take it a third time? No, because I didn't say until you pass the test. I said you got 2 options. You got 2 chances. That's a fixed number. You can pass it the first time. If you fail it, then you have a second chance to take it. If you don't pass the second time, that's it. You have a fixed amount of times you can take the test. These are the 4 rules for binomial. That's when you know it's a binomial distribution. And we're going to talk about something else. We're going to do an example after this to show you how to tell if something is a binomial distribution or not. Okay. All right. So good that you got that. Okay. So now we got 69 and 70 out of the way. All right. So let's look at 73. I want to keep these rules up here because we're going to use them again and again and again today. All right. So the next problem would be what, 73? So 73. Okay, so 73, you can talk about again the rules. So the reason why 73 is not a binomial distribution, all 4 of the conditions not met. So not met because each trial the probability P, which is your success, what you're looking for, you can think about it as your event, is not the same. For every situation. All right, so I'm going to read the question and I'll tell you why. Okay, it's for 73. Okay, National Football League kicker has made 80%. So that's going to be your success. Success is going to be, what's that? 0.80. Okay, so you're either going to make the kick or you're going to miss the kick. So this is going to be a probability. Each time it's going to be the same. Okay, so they also told us that you have 20. So n equals 20. That's your fixed number. But if you look at the very end, they talk about in different ways on 73. They say he's going to kick it at attempts differs widely. It's the distance, the angle, and so on. So all the conditions, all the probability of success are not all the same because you got different scenarios for each one. So that in that case, rule 4 is not going to be met because each of the trial probability of success is not the same. No, no, Amani. All right, so I hope that makes sense to you. So just got to remember, you got to make sure all four of these rules are met. If one of these rules are not met, that means that it's not a binomial distribution. Okay. All right. So the next problem is 77. So does this make sense? I'll tell you later. All right. So let's get to 77. All right. So 77, remember, we talked about yesterday your individual binomial distribution formula is what? It's going to be probability that X is equal to K. It's equal to N, choose K, your probability of success raised to your K times your probability of failure, which is 1 minus P times your sample size minus what you're trying to, at what position you're trying to find. So it said exactly. So when you use this formula, this is just for exactly. Okay, that's why you got your graphing calculator in case you have a lot of them. Now, so for number 77, they told us that K is equal to 4, and the sample size is 7. All right, and so now they told us about binomial distribution. All the rules are met for binomial. So now we can use this formula. So remember, this is N choose K. So 7 choose 4. And we have success. Oh, so success was what? 44% for each in the very beginning. So we're going to do 0.44, and we got to raise that to the K. K is 4 times, we got to do the complement of 0.44, which is going to be 0.56. Then now we got to do 7 minus 4. So that's going to be 3. Again, yesterday, when we talked about your exponent should equal to your sample size and your basis should equal to 1. So now remember we did here, I showed you how to use combination. So in other words, these are all the possible outcomes for 7 choose 4, and then the order does not matter. Okay, so when you did that, you should have gotten 35 for this. Then you're going to multiply times your success, and you're looking for when the success exactly at the 4th position. Then you got 0.56 raised to the 3rd. So these are your failures. So remember, if they're independent, you got to multiply times that outcome raised to that power. So since we're looking for the 4th success, so we're going to take 0.4 and we're going to raise it to the 4th power. Because it's 4 of them, so and they're independent, so we got to do 0.4 raised to the 4th, and then we got 3 failures, and the probability of failure is 0.56. So we got to raise that to the 3rd. So when you're done, you should get, rounding 4 decimal places, 2304. So they ask you to interpret that. So what this saying about 24.0% of exactly 4 out of 7 people, U.S. citizen, has a O-type blood if picked randomly. So I hope that makes sense. Okay, cool. So we got 77. So I say, yep. So everybody else, it makes sense. But remember, these rules have to be met. Okay. All right. So what I want you to do now is the stuff that I talked to you yesterday. I'm going to give you some problems, and we're going to do we got to do 3 things to it. Okay. I'm going to give you a table. We're going to go back and do what we did on the previous section. we're going to find the expected. Expected mean expected standard deviation. Then once we make a table, well, I'm going to give you the table. We're going to graph it, see what the distribution looks like, describe the distribution. Then I'm going to show you something new. Okay. All right. So I'm going to erase this, and I'm going to put you a binomial Oh, nope. I'm going to put up a discrete random variable table. And when I put discrete random variable table, we're going to check and see if the table that I've given you, if it's a binomial distribution or not. Okay. So we got the discrete. What's going on? What did it say? Oh, I'm sorry. We'll do 77. I got you. My bad. Okay, for 77, it asks us to find. So for 77, it asks us to find. So if we do 77. Four more. Okay, so for 77, we know that n is equal to 7. We know that p is equal to 0.44, right? All right, so they want to find the probability that x is going to be greater than 4. All right, so isn't that the same as saying the probability that x is going to be greater than or equal to 5? So we talked about that yesterday. So basically all you need to do here is, so that's the same as saying the probability that x is equal to 5 plus the probability that x is equal to 6 plus the probability of x is equal to 7. So you can do your binomial CDF, because CDF means cumulative, and then you're going to do your sample size, which is 7. All right, and then you want to do your probability, which is 0.44, and then you're going to do from 5 to 7. And then when you do that for 77, you should get 0.1402. But we talked about this yesterday, and so we should know how to do this because I showed you how to do the CDF. So CDF is you basically doing, you can let, this is your lower bound. And this is your upper bound. This is your probability of success. No, I'm sorry. This is your N sample size. This is your probability of success. And then this is the cumulative if you do that. So if you say greater than 4, you can also, since it's a discrete random variable, you can do x is greater than or equal to 5. So how you put in your calculator, you're gonna go to menu, go to statistics. It's just the same way we did it yesterday. Brianna, I showed y'all how to do this yesterday. Okay, so go to page, what was it, 389? Yeah, if you go to page 389, if you have TI 84, the instructions on page 389. Remember, Jennifer showed you how to do it yesterday on 84. All right. So if you have an Inspire, if you go to this, so you go to menu. If you have an Inspire, you go to menu. You go to for menu. You're gonna go menu. Then you're gonna go to statistics. Then you go to distribution. Okay, then 4, you're gonna go to binomial. You can scroll up if you want to get to it quickly. Then you have binomial CDF. Then it should have N. Then you're gonna plug in 7. Then you're gonna have P. You'll plug in 0.44. Then it's gonna say lower bound. And that's going to be, in this case, 5. And your upper bound is going to be 7. Then all you have to do is click on OK and hit enter. And you'll get the number. Okay, good. So again, Brianna, you can always reference. So what I want you all to do is practice doing this. So it should be automatic when you take the test or you take the AP exam. I don't know if we're still gonna have it. Okay, but even if you're in college, you should practice this so it should be automatic. All right. All right. So that's 77. So now we're gonna move on. So you get it? So do we get it now? Yes, no, maybe. Okay. All right, good. All right, now, so what I want you to do now is I'm gonna give you a discrete random variable table. And so we got any other questions before I move on? So we're going to text this man and all this other mess. So we're good? All right, so with this information I just put on the board, I need you to find the expected mean and find the expected standard deviation. All right, I'll give you time to work it. Thank you, Tyler. All right, once you get the answer, just put it up here and we'll go over it. Outstanding, Danielle. Angela, that's the variance. Find the standard deviation. Anybody else got a different standard deviation? Marie, what you get for your standard deviation? Kendra? Jennifer, what did you get for your standard deviation? Well, Angela, if you messed up, that's okay. We're learning. Okay, Marie. All right. So these are the answers, folks. These are the answers. Amani, nah. Okay. So these are the answers right here. So double check. So y'all do it once again. Remember, we did these formulas already. So we're gonna do this again. Do it again. So these, you should get these two answers right here. If you have to do this, this would be 0 times 0.160 plus 1 times 0.3124 plus 2 times 0.3364 plus 3 times 0.1811 and so on. Then when you sum it up, you should get something very close to this. Then for this one, you should have gotten your first answer. So you should have gotten, what is it? 0 minus 1.7502 squared times the probability that's assigned to it. Then you keep going till you get the last one. So that would be 5 minus 1.7502 squared times the probability that's assigned to it. That make two of us, Amani. But if you do this 6 times, add it up, you should get very close. You should get this, very close to it. And use your Inspires class. You can use a TI-30, but your Inspires gonna give you get the answer quickly. So if you got to use your TI-30, you're doing too much work. Well, this is your answer, Amani. This is the answer after you take the square root. Oh, well, we'll fix that this afternoon. Just where's Gabrielle? Just work with Gabrielle for today. Just work with Gabrielle. You all just share the calculator. But I get your calculator there, I promise. All right. So all right. So you saw how we got these. So these are the answers that we got, right? All right. So we know that we said n was equal to what, 5? And we said that the probability of success, oh, you all don't know, but actually I did it beforehand. So the probability of success is going to be 0.35. Now, if this is n is 5, this is 0.35. If I know that, so to tell that this is a binomial distribution, if I use a rule, they told us that if it's a binomial distribution, you don't have to do this anymore. You don't have to do the outcome times probability and sum them up. You could just simply do n times p. So if I do 5 times 0.35, I'm going to get 1.75, which is this right here. And then if I want to find the expected standard deviation, I'm going to take the square root of n times p times 1 minus p. In other words, your sample size times your success times your failure. You're doing the square root of that. So when you do that, you should get 1.067. So this will always, you can only use these formulas if these 4 rules are met. If that's the case, we don't have to do your outcome times your probability for each one of these and sum it up. We don't have to do that anymore, only if it's a binomial distribution. You just put it in the form. Angela, remember, if you do the table, all you have to do, if you do a table, all you have to do in the formula, you could just do the square root of this right here. You do the square root of whatever you name your x, your x value, outcomes, minus the expected mean squared. You're going to actually put the number for expected mean here, squared times your probability that's assigned to this outcome. Oh, I'm sorry. You could type in this. Okay, you could type in the sum, then put this in parentheses. Then it'll give you this, just like we did yesterday. Or you can just simply find the variance and you can find the square root of it. Yes. I don't know who ALS is, but yeah, wow. All right. But again, you can only use this formula if it's binomial. If it's not binomial, you can't do this. Okay. All right. So what I need to do is erase this. Okay. So if they give me this set of data, and if they turn around and give me the sample size and the probability of success, and I know it's a binomial distribution, when I do it the long way and when I do it this way, it should be equal to each other. All right, so I'm going ahead and erase this. Now I'm actually, so now what is the distribution? Just look at it. You don't have to do. You don't have to do a histogram representation of it. Just look at the numbers and tell me what you think the distribution looks like. Well, I guess I can. Yep. Outstanding, Jennifer. Good job. So you can you could have just looked at this, because you look at this, this is you just going, so here it's going up, go peak, then it just goes down. So you can also look at these, look at the table, and to see that it's skewed to the right. Okay. So we're good. Everybody see that skew to the right? Marie, Danielle, Victoria, Angela. We're good. Brianna. Okay. All right. So we're all good, right? Okay. So what we're going to do now is I want you to do a table on your own and tell me what to do. And we're going to do the same thing for here. All right. So we're going to cross it. So we're going to take this out. I want you to put them on the same page because we're going to compare them. All right, so now we're going to do the probability. We're going to have P is equal to 0.65 and N is equal to 5. So fill these numbers in and then do a graphic representation of the data. The probability is now of success is 0.65 and the sample size is 5. Well, Gabrielle, I'm so sorry. If you got the right answer, then you good. I will look for Gabrielle from now on, I promise. between. Remember yesterday how I showed you how to do this, how to use the table. So it's use what we did yesterday. So yes, you do. I'll help you out. I'll put the first part of it. Yeah, the binomial PDF. That's right, Destiny. Outstanding. Nope, we have to do the individuals. So individuals. So you can't do cumulative, individual. So I'm gonna put the first answer there to let you know you're on the right track. Skewed to the left, huh? All right, so good job, Victoria. Angela, remember we did here yesterday? We did the table. So we put the outcomes here. So that's 0, 1. Then we put the probability here. So it'd be probability. So I'm gonna write it down here. So I'm gonna write it here. So that would be probability this, and then you're gonna do the binomial PDF, and so that would be 5, comma point 65, and then you would just do so you do PDF, and then you're just gonna put outcome here. So you're gonna put that here. And then you hit enter, then have your individual probabilities. Which is 5. And then put in. No. Okay, so Jennifer, when you do a PDF, they don't ask for a lower bound or upper bound. They just want the individual number. So you can put in what you can put in list. You can put in list 1. You don't have to change it all. Just do so. You could do your you could do your binomial PDF. So you could do your binomial PDF. Then you're gonna put in your sample size. You're gonna put in your probability. Then for that third space, you're just gonna put list 1. Then you want to store that in list 2, like we did yesterday. And then when you do that, that's going to give you your individual probabilities, but it's going to be in your list 2. That's if you have 84. So did you get it, Jennifer? Well, I'll give you a minute to do it. Just let me know. Okay, good. All right. So if you were, okay, you're welcome. Okay, so now if you were to put 0.5 in here, 0.50 for your probability, it will give you your distribution will be symmetric. So if you come here and you want to change your success to 0.5, it will be symmetric. Your distribution will be symmetric. All right. So I just wanted to show you that. All right. Now, because I want to get geometric done. So now we're just gonna go on to. I'm gonna show you how to find a probability inclusively and exclusively. Okay. So I'm going to erase this, and we're gonna keep this problem here, and we're gonna find some probabilities. So I want you to find the probability that x is greater than 1. Then find the probability that x is less than 3. And Gabrielle will be looking for them answers. That's greater than. That's greater than 1. Okay, got 8. 875. Okay. So we got the probability that x is greater than 1. So wouldn't that be the same as saying the probability that x is going to be greater than or equal to 2? So wouldn't that just simply just be we're greater than 2 equal to 2. So can't we do 0.0053 plus 0.0488? Because we're looking for this 2, 3, 4, and 5, right? So if we put that in the calculator, all right, Angela. Okay, so Gabrielle, you was a little off, but it was close. All right, now, but thank you. All right, now we got to do the probability that x is going to be less than 3, right? So is that the same as saying x is going to be less than or equal to 2? So if that's the case, we're just going to do 0.0053, 0.0488, and then we have 0.1811. So that'll be 12, carry number 1. So that'll be 5, carry number 1. That'll be 5, carry number 1. Ooh, what was I thinking? Should be 3. So that's 12, 13, and then that's 2. All right. Okay, so if you're looking at this one, it's an x is greater than 1. So that means it's greater than 1. So since it's discrete, we can't count 1. So it's 2, 3, 4, 5. So don't we have to take out 0 and 1? So we're going to sum this up, do 1 minus that. Now, if we're looking for x is less than 3, so we can't include 3 because it's mutually exclusive. So we can only do 2, 1, and 0. So this is going to be P x is equal to 0. This is x is equal to 1. And this is x is equal to 2. And all these 0, 1, and 2 is less than 3 because it is a discrete random variable. All right, does it make sense? I see that you are talking amongst each other, which is good. But look right here, let me know that you understand. And we're gonna do one more thing, and we're gonna stop. We'll just finish up tomorrow. So I go back and adjust. I know it's 1:30. I just one more thing. We're gonna stop. I promise you, Jennifer. Okay, good. All right. So it's one more thing, and then we're gonna stop. We'll finish up geometry tomorrow. Okay. So good job, Abby. Okay. Gabrielle, makes sense. Thank you. It's 2 L's, but you know that. All right, now. So we got one more thing and we'll be done. So now I want you to find the probability that x is between 1 and 5 exclusively. Then I want you to find the probability that x is between 1 and 4 inclusively. And then we'll be done. You just getting your numbers off the table. You don't have to use your calculator. Just look it off the table. You don't have to go to PDF and all that. Just put in your calculator. I mean, just look at the table and find the numbers. So if you was doing this one, exclusive mean that it's not included. So exclusive in between. So that's going to be the probability that X is strictly in between 2 and 4, which is the probability that X is equal to 2, probability X is equal to 3, plus the probability that X is equal to 4, because these three numbers is exclusively in between 1 and 5. And you should get, let me see, Gabrielle is the winner. Good job. Still a knucklehead. Now, okay, so this is going to be, so you should get 0.8271, I'm sorry. 8271. Now, if you do inclusively, you have to include 1 and 5. So that's the probability that X is greater than or equal to 1 and 5, because you have to include 1 and 5. So basically, if you want to do this, that's going to be 1, 2, 3, 4, 5. That's why the complement rule is so very important. You could just do 1 minus the probability that X is equal to 0. And so then that would just be 1, 1, 2, 3. So what's the answer for the last one? Yep. Ms. Reyes, that's it. All right, so we're done. I go and readjust the you know what? Just hold off. So we don't have any homework for tonight. Okay, so tomorrow I will show you how to talk. We'll talk about how to use the binomial distribution to use a norm curve. Take a binomial distribution and change it to a norm curve. So what else we'll do that tomorrow. So don't worry about homework tonight. Okay, and we'll start tomorrow. And I did not mean to run over, but hey, it is what it is. Okay, now I will see you all tomorrow promptly at 12 o'clock. No, I'm not singing. Will you leave me alone about that? I'll do it when I see you live. All right, I'll talk to y'all later. Thank you for tuning in. See you later.